morning, class. So at this point we're busy with exercise 9.6. You had to do the even numbers. No? But I realized that I gave you the whole exercise to do. Yes. The day before, isn't it? No, okay. So it was the even numbers you must tackle now from 9.6. Any issues here? With number, you had to do the even numbers. Number 2? Any issues here? Number 2? Number 4? Sorry? You should have had a problem number 4. Number 6? Who yet? Number 8? No. Okay. So that takes us now to 9.7. Is that correct? You had to do the odd numbers there. I hope you guys are doing the work, eh? So let's go to 9.7. I said I was going to do the examples first, no? I only did one example yesterday.
Yes.
Right. Yes, Michael? But what does question 2 read? Huh? So the answer is given next to the sum. Yes, because if you look at number 2, it says prove that that angle is equal to that angle. So, if you can... Come on now. Right, yesterday we did number 1. Not so. So let's do number 2. Example 2. Well, you cut number 2 already. Why didn't you tell me I did it already? It's now wasted a couple of minutes of my life. Okay, let's use the one I just cut so I don't feel like I wasted my time. Right, so we're looking at example 2 on page 317. Yes. Hey. Thank you. So we're told that TR is a tangent to the circle at R. Why? What? Looking out of the window? You're looking at your textbook in the window. So, oh, nice. Nice. I like it. Okay, so we are told that TR is a tangent to the circle at R. So what can be deduced from that statement? We can say that angle R1 is equal to angle M2. Why? Tan cos theta. Or R2 is equal to P. Why? Tan cos theta. Okay. Then we are told that PM is the diameter produced to be the tangent at T. So PM is a diameter, which means a tangent at T. So if it's a diameter, what can we say from there? R3 is 90. Why? Angle in semicircle. Nice. Then we are told that TS is perpendicular to PT, 90. So what can we see from there? What can we see from there? R3 is equal to P, TS, or STM or STP. And if that angle R3, if that angle is equal to that STP, then what do we know? We know clearly that M or TMRS will be a cyclic quad. On what account? Exterior angle is equal to the interior opposite. You understand? Carry on reading. Produce meets TS at S. So we are told that PR produce meets TS at S. MR is drawn. Prove that TMR is a cyclic one. And there we've done it already. Not so? You all okay with that? Right, so let's do the layout. So we first say, we just need this, not so. So we're saying that R3 is equal to 90 degrees. Why? Angled in semicircle. So now we state the obvious, not so. So we say since R3 is equal to STP, which is equal to 90. Therefore, TMRS is a cyclic quad. Why? Because the exterior angle equals the interior opposite angle. Okay. So now that means to say all cyclic properties are evident or can be used in that case thing. Okay. Let's look at B. R1 is equal to angle S. So angle R1 is equal to, how is R1 equal to S? It's never going to be exactly straightforward like that. We must first go into another angle before we get to that. So which angle is equal to R1? Any angle, which angle is equal to R1? R4. Why? Vertically opposite. R4 is equal to what? M2. Why? Tan cotherum. M2 is equal to what? S. Why? Exterior angle of cyclic quad. Remember, TMRS is now a cyclic quad. So I can use the cyclic quadrilateral properties in that quad. You understand? So where do we start? We say let is either you can let S equal to X or R1. I always start with the one on the side. So let R1 equals X. Again, if you that type of girl that they want to bring the X into it, you leave it out. Okay? Doesn't deserve a place in your life, no? X. So we're saying R4 is equal to X. Why? Vertically opposite. Right. Now what? M2 is equal to X. Why? Tan cotherum. Then we said that angle S is equal to X. Why? Exterior angle of a cyclic quad equals the interior opposite angle. So therefore, R1 is equal to S is equal to S. Okay. Any confusion here? Any confusion? No? Let's look at example 3. Example 3 is on page 318. So we are told that A, B and C, D are two parallel chords. A, B, I think I'm going to make this a bit bigger. A, B and C, D are two parallel chords. So if those lines are parallel, what do we know? B3 is equal to C3. Why? Alternate angles. What else do we know? Sorry? B1 B1 plus B2 So you're saying that D is co-interior. Nice. What else? B2
and B3, like B2 plus B3 is equal to PBC.
Why?
Corresponding.
Corresponding. So you're saying that this angle here is equal to that angle. Nice. Corresponding. And I'm sure there's many other things you can say about this book. Not so. Let's just put those dots there for now. Then we are told AC and BD are both produced to intersect at P. So AC and BD are produced, which means to extend it to intersect at P. Then we are told the tangent to the circle at B. So if this is a tangent, what do we know? The tangents, there are two tangents to the circle at B and C, intersect at Q. So those two tangents intersect at Q. So if those are tangents, what do we know? They're equal, yes. So QP is equal to QC. What else do we know? C2, yes. Is equal to D1. Why? It's equal to B2, yes. Why? Tan code here. B1? C5? It's also equal to B3, yes. So you'll get one dot there, yes. Tan code theorem. What else do we know about B1?
B1 is equal to C3.
B1 is equal to C3. B1 is equal to C3. Why? Tan code theorem. What else? C1 is vertically opposite here. Nice. No? So we got many angles known there to us. B and C are joined. Prove that C1 is equal to B3. C1 is equal to B3. Can you see it has one dot dot? So we already done the job. Can you see that? That's why it's important to read and plot as I'm doing it. Alright? Give us a feel for the diagram. So let's go. Hey. So we say let. Then what? C1 equal. So if C1 is equal to X, what do we know? We must end off with B3, which is here. Which is there. C5 is equal to X. Why? Vertically opposite. Now what? C5 is equal to B3. Why? Tan code. So therefore, C1 is equal to B3 is equal to X. There we done the job for it. Okay? I'm going to take this off because it's on the diagram. Okay? B1 is equal to B3. So B1 is already, B3 is already X. So if I can prove B1 is X, I've done the job. Not so. But B1 is equal to C3. Not so. And C3 is equal to B3. So the job is done. Can you see that, people? So let's go with that. So we're saying that C3 is X. Y, alternate angles with BA alternate angles with BA being parallel to CD. Not so? You see the Z there, no? Then B1 is equal to C3, which is XY. Why is that X? Tan code theorem. So therefore, B1 is equal to B3, which is equal to X. Any confusion here? You understand? You all understand? Who's coming for this afternoon's lesson? Yeah, I thought it was Thursday today. You guys know that you have lessons for you on Thursdays, no? But nobody comes. Every Thursday I cry here by myself. Huh? But then I mark your exam and then I wonder, why am I alone? But anyway, C. C says, prove that BCPQ. BCPQ is a cyclic chord. There are three ways of proving cyclic chords. What are the three ways? Exterior angle of a chord is equal to the interior opposite. Or opposite angle supplementary. Or equal angles subtended by the same chord. And that's the one we're going to use. See, there's many lines with diagonals here, we can see it. Here's it. Can you see that, people? You see here, this angle here is equal to that angle. So it's a cyclic chord. So no lead up to that. We can state the obvious immediately. Not so. So we say since what? C1 is equal to B1, which is equal to X. Therefore, BQPC is a cyclic chord. Why? Because we are equal chords, equal angles subtended by same chord. Equal angles subtended by the same chord. Therefore is a cyclic. Okay? Any problems there? Any issues? Right. 9.7. And 9.7 is on page page 319. And that's what you had to do most for homework now, no? So I'm gonna hear from you guys now more than what when we did the examples, no? People, we are told that ABCD is a cyclic quadrilateral. So by ABCD being a cyclic quad, what can be derived from it? Yes, good start. Sorry?
C3
Uh,
is equal to BAD.
say again?
C3
C3 here.
is equal to BAD.
So there's an angle here. Why? Exterior angle society. Nice. What else?
Also equal to D1.
But we're not even by the 70th. Oh, equal to D1.
For the
No, I'm talking for the fact that ABCD is a cyclic quad. That just saying that.
Sorry,
It's okay. Yes.
angle C1 plus C2 plus angle DAB is equal to 180 because opposite angles are cyclic.
Nice. Opposite angles of a cyclic quad is supplementary. That's correct, yes. And D1 plus angle B is equal to 180. Opposite angles are supplementary. Then we are told that DE is a tangent. If D is a tangent, what do we know from D?
D2
D2, yes.
A2
Equal A2. Why?
with tan
Nice, stand for theorem. Then we are told that AD is parallel to BCE. What can we say from D?
A2 is equal to C1.
Why?
Alternate angle.
Okay, good, well done. You see that, people? Alternate angles. Then we are told that AC is equal to AD. AC is equal to AD. What can be determined? What can be derived from the C2 is equal to D1. Why? Angles opposite equal sides. Then yeah, keep on believing that. Then we are told that DC is drawn. C3 is equal to 70 degrees. C3 is 70. Write down, giving reasons, 3 other angles equal to 70. So you got 1. Where's 2? B? A? D. No, that's was 1.
Oh, and D1.
D1. Why D1?
Alternate angles.
Three angles equal to 70. That's your exterior angle of a cyclic quad. D1 is 70 years, why? Alternate, yeah. You guys said something else. You said alternate. Yes, my ears is at 9 too. Okay. You're absolutely correct. I didn't hear it, okay? Right, so we're saying that UBET is equal to 70. Why? Exterior angle of a cyclic quad equals the interior opposite. So there we go, 70. Then here's your alternate angles here. Not so. So D1 and 70. So D1 is equal to 70 degrees. Why? So alternate angles with BE being parallel to AD. Then C2 is also 70. Why? Angles opposite equal sides. Okay. So there I got 3 angles equal to 70. Okay. So since that is on the diagram, I'm going to take this off so that I can keep the diagram in focus. Okay. Let's look at B. Calculate the size of C1. How are you going to calculate C1? Angles on a straight line. So C1 is equal to 180 minus 2 by 70, which is 40 degrees. Is that correct? You must write this straight line. 40. In C, name giving reasons, two other angles equal to C1. Two other angles equal to C1. A2 is equal to 40y. These alternate angles in, with BE being parallel to AD. One more. D2 is 40. You guys copied well from the back of the book. And why is that 40? Tan 40. Okay, and then we've done the job. Not so? Yes?
For B, you trying to use optic angle side before calculate.
To work out?
For B.
Yes! How can it not be? She's absolutely correct. By saying to calculate C1, it's going to be 70 plus C1 plus 70 equals 180. Opposite of angles of side equality. Absolutely good. Okay. Any confusion here? No. Okay, we'll do another one. Sums is nice, ne? Sorry? Yes, 5 comes after 3. Don't you want me to do 3? Okay. Right. So we are told, given radii OP and OM. So if OP and OM is your radii, what do we know from here? Huh? OP is equal to, yeah, it's your radii. But what can we derive from it? Angle P2 is equal to M2. Why? Angles opposite equal sides. So P2 is equal to M2, angles opposite equal sides. Then we are told that O is the center of the circle, chords PM and MQ and OP are drawn. So if this is drawn, what do we know? We know that O1 is double angle Q. Not so. Why? Angular centers twice angular circumference. So we know that that is also equal to that. Then we are told that are drawn. MN is a tangent such that PN, so if MN is a tangent, what can be derived from here? M1 is equal to Q. Why? Tan theorem. Girlfriend, why are you talking to that cousin? Yeah. We must all family in a way or another, not so? All come from Adam and Eve, isn't it? Okay, so we're all family in some way or another. Right. Maybe 150,000 generations above. You share a grandfather or something. Right. So you are maybe you were ape, not me. No? I don't believe I was ancestors was apes. Okay. When Darwin wrote his theory, no? He himself said in the letters, he himself is confused about this theory. You know that? Read it when you go see. He himself says he's confused. So how we fasting? Can you now believe in what he said? That your forefathers were apes? Scientific. He was a scientist and he says confused. And many other scientists are confused.
Didn't Darwin come from my community?
From where?
Yeah. Because I'm pretty sure that he did, because most of like the
cradle of humankind in Africa. Like, like most of the
Most of the apes.
yeah, most of the slaves for you in Africa at the bottom of Nigeria.
So why was it only at one point that it evolved and is never evolving ever again? You know what I'm saying? It's time. Okay. I don't believe. But anyway, what I believe is not important. Here we go. So we are also told that Pn is equal to Pm. If Pm is equal to Pn, what can be derived from here? N is equal to M1, which is 25. Can you see that, people?
Yes.
Now it says, calculate giving the reason the size of angle Q. Can you see? Angle Q is already marked. So somehow or other I can lead it up to that. Okay. Verstaan julle? Alright. Hier gaat ons. So we're going to firstly say that M1 is equal to 25. Why? Angles opposite equal sides. Right. Then what can we say? Q is equal to 25. Why is angle Q 25? 10. Then? Oh, that's all they wanted. Not so?
Yes.
Right. B. I'm going to take this off since we have that already here. So B, M2. So we know that M2 is within this triangle here. M2 is the same as P2. And at that point I can calculate O1. Not so. So angle O1 is equal to 50 degrees. Why? Angle at center is equal to 2 times angle at that's 50. So what can I say now? M2 is equal to P2. Why? Angles opposite equal sides. And it's the fact that it's your radius. So remember they wanted M2. So M2 plus P2, which is also M2. 2M2 plus 50 degrees equals 180. Why? Sum of triangles, and it's triangle POM. Yes. Sorry? Sorry? This means yes? Sorry? Yo, that was much easier. Come inside. So that would be 130 divided by 2? 65. And share the easier way. Absolutely. Instead of that, you could have just said that M2 plus 25 is equal to 90 degrees. Why? Radius perpendicular to tangent. So M2 is equal to 60. Who saw that? Okay, you guys are sharper than me. Nice, well done. Right. So in our next lesson, we will conclude the odd numbers of this exercise. So for homework, I would like you guys to do 9.7, the even numbers. Okay. People enjoy the rest of your day. Good afternoon, class.